All right, so can you guys see my screen now? Hello? Can you see my screen or no?
Yes, sir.
All right. So I hope you guys have done an advanced reading regarding with our module 3. Okay. Well, this is only slide 32. Yeah, 32 slides only. So this will only take short, maybe 1 hour and 30 minutes, more or less. All right. So without a further delay, let's start. So the topic for module 3 is sequences and strings. Okay. So of course, first we have to know what is sequence. So from the meaning of it, it's a list of objects arranged in a definite order. So take note, it's a definite order, meaning arrangement in sequence is very important. So unlike sets, it is not that important, but in sequence, it is very, very important. So this same concept, it could be either finite or infinite sequence of objects. And then that elements under sequence could be distinct or repeated. Okay. So in set, it is distinct, but it is not repeated. Okay. So that's their only difference. So in sequence, it's arranged and it's repeated. Right? So we have here examples wherein we have 1, 0, 0, 1, 0, 1, 0, 0. As you can see, this one is finite and repeated. For the next example, we have 3, 8, 13, 18, 23. So as you can see, this one is infinite. Okay. Just by putting 3 more dots, okay, indicating that there's more elements from it, okay? And at the same time, this one is distinct because this one is exclusively, like if you're going to take a look at this one, 3 followed by 8, followed by 13, 18, and then 23. As you can see, there is a pattern, right? What is that pattern? Hello, guys. Can you guys
5,
still
sir.
follow? So this one is, or the second term can be identified just by adding 5 on the past term. So 3 plus 5 is 8. So for you to be able to identify the next one, so just add 5. So 8 plus 5 is 13. Then the same. Next one. So 13 plus 5 is 18. And then 18 plus 5 is 23. So as you can see, this one is distinct. Or in other words, we call this one recursive. All right. So when we say recursive, okay, I'll make it short. When we say recursive, the past terms are important for you to be able to uh, get the next term. Okay. So what is the third term? You have to know what are the past two terms. What is the fourth term? You have to know what are the past three terms. Okay. So from that, you will see the pattern and then you will know what to do and how to get the next term. Okay. So we also have this one, 1, 4, 9, 16, 25. Okay. This one is the least of squares of all positive integers. Okay, so you could say that this one is also distinct and infinite, but this one is more on explicit. Okay, so the difference between explicit and recursive is for recursive, you have to know the past terms, but for explicit, you only need to know the formula. Okay, there is actually a given formula. We're in here, it says here, list of squares of all z plus. So z plus are positive integers. Wherein in positive integers, you will start with 1. Okay, onwards, 1, 2, 3, 4, 5, up to infinite. And then just square it. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on and so forth. So from there, you don't need to know the, what are the elements on the first, second, third. All you need to know is the formula, okay, which is this one. That is why it's called explicit. All right. So did you guys get this one so far? Hello?
Yes, sir.
Right. So I hope this one is clear. So it's finite and repeated, it's recursive, and then it's explicit. All right. So we have here the kinds of formula. So we will start with the recursive. So as I said a while ago, recursive is a formula that refers to previous terms to define the next term. So you have to know the previous terms for you to be able to know the next term. Okay. So it must have a starting number. So if there is no starting number, then that must be an explicit formula, or that must be an explicit kind of sequence. Okay, so we have this sequence 3, 8, 13, 1823. So the same, this one is example from the number 2. So a sub 1 here is indicating that this is the first term. Okay, a sub 1 is 3. Okay, and then we have this formula wherein a sub n is those terms. So first, second, third, fourth, fifth. And then this a sub n minus 1 plus 5. So as you can see, uh, for you to be able to get the something, okay, or something position, first term, second term, third term, fourth term, you have to know what is the last term or the value of the last term. Okay, so from there, you could substitute the value of that first term in here, and then you will be able to get this second term. Okay, but before that, okay, you have to know that the range of this one should be start, okay, 2 and above, or equal to 2 and above, right? Because this is already the a sub 1, right? And then this is the a sub 2, which is now this one. Okay, so this is our starting point. So actually, you can remove this one as long as you know the first term and then you know the formula, then you're good to go. You will already know what are the following terms. So for example, this one, you already know the first term, then you will be able to identify also the second term just by knowing this formula. So a sub n minus 1, so just plug in the value of a sub n, okay, or a sub 1 rather, which is this one, plus 5. So a sub 1 is 3, plus 5 is equal to 8. So the same with this one, so you have to know what is the value of a sub 2 for you to be able to get the a sub 3. So a sub 2 is 8 plus 5 again, which is now 13. So again, for you to be able to know the a sub 4, you have to know the value of a sub 3. So a sub 3 is 13. So 13 plus 5 is equal to 18. Sorry, why is this 23? 18. So that's the correction. So I'll just update this one later on. So 13 plus 5 is 18, and so on and so forth. So as you can see, this is our a sub 1. Oops, this one. A sub 1, a sub 2, and then a sub 3, and then a sub 4. So I just didn't include the a sub 5, which is 23, right? So that's the concept of recursive. So you have to know the last terms for you to be able to get the next term. So were you guys able to get this one?
Yes, sir.
All right. How about the others?
Yes, sir.
Yes, sir.
Okay. So I hope you guys really will able to understand this one because this one is super easy. All right. Next one is explicit. So this one is a formula that provides a value of a term using only its position number. Okay. So you don't need to know the past terms, what are the patterns, and so on and so forth. So in here, the formula is already given. Okay, so as long as you know the formula, which is, for example, this one, okay, n squared, okay, and then you have, you know the range, the starting up to the end. So it says here that your n should be less than or equal to 1. Less than? Yeah, less than. Is it correct? Less than 1 or equal? Uh, see, other way around. So n should be greater or equal to 1. Okay. So maybe it would be better if it should be something like that and then 1. Anyway, this one is something like that. So n is greater or equal to 1. All right. So from here, as you can see, this one is has a pattern, the same with recursive. But in here, you don't need to know the first term, second term, third term, fourth term. So in here, as long as you know the formula, then you're good to go. So for example, you want to know the 10th term. So just substitute here the value of 10. So 10 times 10 is 100. That's already your 10th term. Okay. And here, we've only shown up to 5th term. Okay. So 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. And then 1 times 1 is 1. All right. So you could say that explicit formula is a lot more easier than recursive, because in here you have to know the pattern, and at the same time you have to know the formula, okay, the correct formula. So were you guys able to learn the difference between explicit and recursive?
Yes, sir.
Yes, sir.
All right. Okay, so let's have more examples. So write the sequences of the following recursive formula. Okay, so take note, in recursive, you have to indicate everything. Okay, so the steps on how did you come up with C sub 3, C sub 4, C sub 5, and then C sub 6. So you can say that this one is quite a lot longer when it comes to uh, solving things. So let's just say that we will put five following terms. One, two, three, four. Yeah, five. Okay. So your starting point is five, and then here's a formula, and then here's the range up. So there is a range already. So as you can see, this one is ranging from 2 up to 6. So 2, 3, 4, 5, 6. Okay, so that's why we have a total of 5 terms. And then for you to be able to get the C sub 2, you have to know the C sub 1. Okay, so this substitute here. So to our formula, so what is our 2C sub 1? So C sub 1 is 5. So 2 times 5 is 10. And then for C sub 3, you have to know the value of C sub 2. So C sub 2 is 10. So 10 times 2 is 20. And then just keep on doing that. So just substitute the last value and then put it on the formula, and then just multiply it by 2. And then you will be able to get the sequence already. So from here, we have 10, 20, 40, 80, 160. So it keep on doubling its past term. Okay. So just multiply this one by 2, by 2, by 2, by 2, by 2. All right. So were you guys able to get this one?
Yes, sir. Nakuha po.
Okay. So there are two questions when it comes to recursive. So it is either it is asking you the first five terms, okay, which is like this one, or it is the other way around, wherein this one is already given, and then you have to identify what is the formula. All right. So those are the only questions when it comes to recursive. Okay. All right. Next, we have here another recursive formula, okay, wherein our first term is 3, and then here's the formula. So just keep on adding 4. So 3 plus 4 is 7, plus 4 again is 11, plus 4 is 15, and then plus 4 is 19. And so on and so forth. So just keep on doing that one, and then you will get all of the possible terms for this sequence. So 7, 11, 15, 19, 23. Okay. So are we clear so far regarding with recursive formula?
Yes, sir. Clear naman po.
Okay. Is there anyone who's confused? All right, so I guess not. So in recursive, the one thing that, or the first two things that you need to look is the starting point, and then what is the formula, and then the last one is the range, okay, or where were you going to start? So in here, you're going to start at 2. All right. So once you're done in understanding those examples, so of course you're going to have a seat break. Okay. So this one is quite long. So for the first one here is the write the sequence of the following explicit formula. Okay. State note this one is explicit. formula. So do it handwritten, and then of course, please write logically and then take a picture of it clearly. Okay. So we have here number 1 and then number 2. And then for number 3, we have this one. So blue taxi, blah, 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 blah. And then this is the mileage, and then this is the cost. So we have 2 questions here. So write the recursive formula for this one, and then write the explicit formula for this one also. All right. So I'll give you guys 10, 15 seconds to take a look at this one. Okay, so is it clear? Is the instruction clear?
Yes, sir.
All right. Of course, after this, there is a continuation, which is number 4 and number 5. So if the sequence formula is given as t sub n is equal to n squared times 1, wherein n is less than, greater or equal to 1, so write the first 5 terms of this sequence, and then find the 55th term for this sequence, or for this, or using this formula. Okay. And then for number 5, the sequence is defined as x sub n is equal to 1, 2 raised to n. And then your n is ranging from -1 to 4. So write the elements of the sequence. So in here, just write 5, the first 5 terms only. You don't need to write everything. So -1 up to 4 only. Okay. So are we clear so far regarding with number 4 and number 5? -1, 0, 1, 2, 3, 4. Sorry. This one is 6th term. Okay. -1 to 4. 1, 0, 1, 2, 3, 4. Yeah. 6 terms, including the 0. So is the number 4 and number 5 clear so far?
Yes, sir.
How about the others? Nag-breakfast pa kayo?
Yes, sir.
Makain na ba habang nakikinig? Alright, so I hope you guys have already ate your breakfast, so you have mood to listen with our, or in our discussion right now. Alright, so that's it for the seat break number 1. So let's now proceed to the next. So next one is types of sequence. So we have 2 types of sequence. We have the increasing sequence and then the decreasing sequence. So as you can see, this one's very obvious and self-explanatory. So increasing sequence is, of course, any pattern as long as it's increasing. So as you can see, this is a sequence wherein it's increasing. So 2, 4, 6, 8, 10, 12, 14, and so on and so forth. Okay. So in a sequence, there is always a pattern. You just remember that. So it's not just increasing randomly. So it's not like 2, 4, 10, 15, and then 18, and then 35. So it's not like that. So in a sequence, there is a pattern wherein in here, it's increasing by 2. Okay. So if we have increasing, we also have decreasing. Okay. Wherein it's decreasing by, like, keep on dividing by 2. Wherein it's decreasing, of course. So starting from 2 became 1, then divided by 2, divided by 2, divided by 2, and so on and so forth. So 1 4, 1 8, 1 16, and 32, and so on and so forth. Okay. So those are the types of sequence. So I guess this one is needless to explain anymore. Anyway, so the next one here is your seat break number 2. Okay. So this one is actually super easy. Okay. Like literally super easy. So write the first 4 terms begin with n is equal to 1 of the sequence whose general formula is given as those. So we have already a given general formula. So all you need to do is write the first four terms of those given formulas, right? So we have this for the letter A. And then we have another one for letter B. So write the formula for the n term of the sequence identified as recursive, explicit, or both. So in here, there's two things that you need to do. So write the formula for the n term, okay? And then identify that formula if it's recursive, explicit, or both, okay? So we have 7 numbers for this one. So you could say that this one is the opposite of letter A, okay? And then for the last one, this one should be letter C. For the sequence B defined by, so V sub n is equal to n factorial plus 2. So your n is greater or equal to 1. So find the value of B sub 3, find the value of B sub 4, and then find the value or the summation of ranging from 1 to 4. So later on, we'll discuss what is the summation, so you can answer this one summation. So as of now, we only know how to answer letter A, letter B, and then letter C, letter A, and B. But for C and D, so we will discuss this one or more example of this one later on for you to be able to answer this part of your seed work number 2. So the same concept. So write it handwritten or late handwritten. If you can do it on the Microsoft Word, then better. But if you're going to do it handwritten, but uh, yeah, if you're going to do it handwritten, please write legibly. All right. So again, I'll give you guys 10 to 20 seconds to take a look on this seat work. So if you have a question or clarification, so just ask me. All right. So is it clear or no?
Okay naman, sir.
All right. So at first, at first glance, this one is quite a lot of work, but actually in reality, this one is super easy. Okay. So that is why there's a lot of numbers. How about the others? Is it clear or no? So let me know so we can explain that part wherein you're getting confused. So how many are we now? So we are now 17, right? So not bad. So before we were 18, 19. Right now we are 17. All right. So any questions so far before we proceed to the next topic?
None, sir.
Answer.
None, sir.
All right then. So the next one is sum and product notation. So maybe some of you or most of you already familiar with this one. So we have this defined as if this a sub 1 is actually the given formula or given notation. So it could be a summation or annotation. Okay, so if it's summation, then you have to get the sum of all of those given numbers. And then if it's notation, then you have to get the product of all of those given product. Okay, so this one, as you can see, I is equal to m, and then we have here letter n. So this is the range of the given formula, okay, or given annotation. So I here is the index, okay, wherein it is always equal with the lower limit, okay. So for example, this one is ranging from 1 to 3, 1 to 20. So your m here is equal to 20, and then n is the upper limit, wherein it is 20. Meaning, you have to get the sum of 1 to 20, or you have to get the product of 1 to 20. So if it's sum, then 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to plus 20. And then if it's product, then it's multiplication. So 1 times 2 times 3 times 4 times 5 up to times 20. Okay. So those are the difference of okay, just the operator. So instead of plus, it's multiplication. Instead of multiplication, it's addition. Okay. So were you guys able to follow this one so far?
Yes,
Yes,
sir. Sa
sir.
example ko siguro is magigets lang.
Yes. What is that? Seems that someone speak quite a sentence, but I didn't understand. I think it's Mr. Agustin. Do you have a concern? You want to say something, Mr. Agustin? All right. So he's not responding. So maybe he just left. Anyway, so this is the uh, bare concept of the sum or the summation and then the geometric, okay, or the product. All right. So let's have an example for you to be able to understand this one. So let A be the sequence defined by an explicit formula 2 times n or 2 sub n. That is A sub I is equal to 2n. Okay, wherein your n is ranging from 1 to 3. Okay, so as you can see right here, we have the summation and then the notation. So for the summation, okay, so we have this formula a sub I, wherein this a sub I is 2 times n. So if you're going to elaborate this one further, this one is actually a sub 1, a sub 2, and then a sub 3. Okay, so where did we get this one? It is the range from the lower limit up to the upper limit. Okay, and then as you can see, this one is incrementing by 1. So it's by it's a1 plus a2 plus a3. And then what is this a1? Okay, so a1 is 2 times n. Okay, so this a is the formula wherein it's 2. This one is this the same with this one. So 2 times 1 plus 2 times 2, which is a sub 2 now. And then the next one is plus 2 times 3, which is the a sub 3. Okay, so just add all of those, then you will get 12. So this is the summation total of the, uh, or let's say this given formula, okay, which is 12. And then for the product, okay, or geometric, okay, so instead of addition, just make it into multiplication. So 2 times 1 times 2 times 2 times 2 times 3 is equal to 48. Okay, so when it comes to summation and then geometric, okay, So the first thing that you need to know is the formula or the given formula. So what is this a sub I? Or what is this I? Okay, sometimes this is only I. And the next one here is what is the range? Okay, what is the starting point? And then what is the uh, limit? Okay, so lower limit and then the upper limit. Okay, so understood or no?
Understood, sir.
All right, so this one is quite easy anyway. All right, so let's focus on summation for now. So this symbol for summation is sigma, okay, or this letter E, look like E. So it takes a sequence of numbers and turns it into a sum. Okay, so symbolically, this is the like the default. Okay, oops, default formula for the summation. So we have the limit, so 0 up to the end, and then we have this a sub I. Okay. So a sub I is starting from 0 since I is 0 up to a sub n since it's quite infinite. Okay, we don't know when will it end. So a sub 0 plus a sub 1 plus a sub 2 and so on and so forth. So this is read as the sum from I to 0. Okay, from I to 0. From I is equal to 0 to I equal to n. So from I to n. Okay, so that's it for the summation. So we have here the continuation. So consider the identity sequence a sub I is equal to I. So as I told you a while ago, this a sub I is just sometimes or mostly just I. Okay, or listing elements of 0, 1, 2, 3, 4, and 5. Okay, so the sum of the first n numbers is given by this formula. Okay, so again, this one is just increasing by 1. So I is equal to 1. So this is your starting point. So you start with 1 and then up to the maximum, okay, or the upper limit. So in here, the first term 0 is dropped. So why is that? Because that depends on the index or the lower limit. Okay, so in here we've started with 0, so we have to include 0. But in here we've started with 1, so we have to start with 1. Okay, so this is your indicator. Where will you start? All right. So did you guys get this one so far? So again, take note that sometimes this a sub I is equal to just I only. Okay, so they are just the same. Any concerns so far?
Wala naman po, sir.
Okay, so just let me know if there is a part that's quite confusing or quite questionable. Okay, so that we can go back on that part and then explain it again. All right, so since we don't have enough time anymore, so we will just continue the rest 15 to 32 on the part 2. Okay, so just wait for my part 2. Okay, since we will start right away once you guys are already in here. So right now there's a total of 17 participants. So once we've completed this 17, then we will start right away. All right, so I will stop this one now and then just wait for the part 2. Okay, so goodbye for now.
Sige po, sir.
All right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
All right, so this is where we've stopped. So any questions so far regarding with the slide?
Wala naman po, sir.
All right, so the next one is arithmetic or summation formula. Okay, so there is actually an explicit formula for the previous example. Okay, so for you to be able to get the summation, this one, so starting from 1 up to the given uh, maximum limit or upper limit, so you have this formula. So as you can see, this one is also quite familiar. Okay, we already uh, had this formula on the, I don't know if it's module 2 or module 1. Anyway, so we have already uh, defined this one using inductive, forget the name. Anyway, so yeah, this is the explicit formula for you to be able to get the summation from 1 up to the given n. So take note, this one is only exclusive, okay, if it's starting from 1 up to, let's say, 100 or 200 or up to its range. But if your I is equal to 2 or 4 or 5 or 20 up to, let's say, 100, then this formula is not applicable anymore. Okay, so it is only applicable if your I is starting from 1. Okay, so from there you will be able to get the summation of that given uh, example or that given range. So in intuitive reason, the smallest term is 1, okay, which is always 1 when it comes to this formula. So the biggest term is n. Okay, so the average term is n plus 1 divided by 2. Okay, so this is the formula on how to get the average, okay, of that given range. Okay, so were you guys able to follow this one? So as of now, this is the first formula that you have to memorize when it comes to summation. So again, this one is only explicit for starting from 1. Okay, so you have to memorize the one. So n times n plus 1 divided by. So are we clear so far regarding with this one?
Yes, sir.
All right. So this one is actually not complete yet. Okay. For you to be able to obtain the final form in having a summation, okay, let's say from 1 to 10, okay, just multiply the average from the or from this formula. Okay. So n minus m plus 1, and then this n plus m divided by 2 is actually this one. Okay, so your m here is your lower limit, which is always 1. Okay, so you can say that this one is n plus 1 already. Okay, coming from here, n plus 1 divided by 2. Okay, so you have this formula, and then you have to multiply this one to the average, okay, by the number of terms. From here, just by applying this formula, okay, then you will be able to get the summation, for example, from 1 to 10. Okay, so what is the summation from 1 to 10? So just follow this formula. So n minus m plus 1. Okay, so 10 minus 1 plus 1 times 10 plus 1 divided by 2. Then just do the math, and then you will get 55. Okay. All right. And then, since we already have this wherein it is not limited by 1 anymore, okay, so it could start with 3 already. All right. So from here, just the same format, okay, just follow this format, okay, or this formula. So n here is 6, and then your m here is 3, and then plus 1. So 6 minus 3 plus 1 is 4. And then just do the math in here. So 6 plus 3 is 9, divided by 2 is 4.5. So 4.5 times 4 is equal to 80. Okay. So you can use this formula, okay, if it's only ranging from 1 up to the given limit. But this one is much more flexible. So this is the easiest way if it's starting from 1. But if it's starting now from 2, 3, 4, 5, and so on and so forth, then you have to use this formula now. Okay. So just memorize this one. So n minus m plus 1 times n plus n divided by 2. So are we clear so far?
Yes, sir.
Right, so I'll just repeat. So use this formula if it's ranging or if it's starting from 1. And then use this formula if it's starting from any number actually. Okay, could be 1, could be 3, could be 5, and so on and so forth. Right? So we have here arithmetic summation example. Okay, this is example number 1. So evaluate the following using arithmetic summation formula. Okay, so we have here the starting point is 20 up to 103. And then we have this given formula, 5 times I minus 3. Okay, so you cannot just substitute the value of I here right away. Okay, so we have this given, step-by-step solution on how did we come up with a more elaborate uh, formula. Okay, so here's the solution. So initially, we just copy this one. Okay, nothing happens, and then we bring out this 5 to this summation. So as you can see, it's now 5 times summation I times I minus 3. All right. Then after that, we've now have this formula. So 5 times summation I minus 5 times 3. So basically, we've just separate this I and then this negative 3. Okay, so it's like distributing this 5 from outside and then separating the 3 at the same time. So I know this one is quite confusing. Okay, well anyway, I have a backup for this one, which is the longer method. Okay, so for now, I will leave this one to you and how did we come up with this kind of formula. Okay, this one is basically algebra. Okay, and then this is already final format. Once you have already eliminated the close enough and parentheses, then you can now proceed and then start uh, substituting their values. So here, 5 is still 5. And then this summation here is actually the n plus m minus n, n minus m, sorry, n minus m plus 1. Okay, so n minus m plus 1. So just follow that one. You will get 100p minus 20 plus 1. So 103 minus 20 is 83 plus 1, 84. So this is our 84, wherein we have 84 or a total of 84 terms times this letter I. So what is this letter I? This is the n plus m divided by 2. So as you can see, this summation I by default, okay, is this one. Summation I, or this summation is the n minus m plus 1, and then this I is n plus m divided by 2. Okay, so one formula and then another formula, which is now this one. So were you guys able to follow up to this point?
Yes, sir. That's the one.
So where this 84 came from? This is the n minus m plus 1. Where is this 103 plus 3 divided by 2 came from? This is the n plus m divided by 2. And then just keep on following this one. So minus 5 times the summation, wherein it's 84. So in here, they just interchange. So times 84, and then the last one is times 3. Okay. Wherein if you're going to solve this one, you will get 24,570. Okay. So that's how you simplify, or that's how you call this one. Yeah, I think simplify. There's no other term that we can indicate for this one. So that's how you simplify this formula to get the total summation from 20 to 103, which is 24,570. So if you wasn't able to understand this one, then we have this solution number 2, okay, which is just the same result but a different way of solving it. So again, same question, of course. So evaluate the following using arithmetic summation formula. So we have this 20 to 103 and so on and so forth. So the same. So if you're going to substitute 20, which is your first term, which is the a sub 1, so you will get 85. So 20 minus 3 is 17. 17 times 5 is 85. And then for the second term is 21, of course. So 21 minus 3 is 19. Yeah, 18, sorry. 21 minus 3 is 18. Times 5 is 90. And then 19 minus 3 is 19 minus 3. No, no. 22 minus 3, sorry, is 19. Times 5 is 95. And so on and so forth. Okay, so as you can see, this one is incrementing by 5. So 85, 90, 95, up to a sub n. Okay, so as you can see right here, the maximum number is 103. So 103 minus 3 is 100 times 5 is 500. So that is our given sequence. So 85, 90, 95 up to 500. Okay. So for you to be able to get this 24,570, you have to know this formula. Okay. So this is the formula on how to identify many terms in total. So a sub n is equal to a sub 1 plus n minus 1 times d. Okay. So this is actually the longer format. Okay. I've just indicated it in here just in case you want to have a longer solution. But as you can see, if you're going to get the total terms for this one, you can actually use this one, n minus n plus 1, okay, which is just the same. Anyway, since it's already in here, so we will use this formula for us to be able to identify the total terms of this given number. So d here is the difference. And then e sub n is the maximum number. E sub 1 is the first term. And then n minus 1 is just in there. N is actually the total term. So just copy as it is and then substitute the corresponding values. So e sub n is, just leave it as it is for now. E sub 1 is 85. Okay. And then plus n minus 1. So d here, so as you can see, what is the difference from the second term and the first term? And then the third term and then the second term. So as you can see, this one has a difference of 5. So just put here 5. Okay, and then distribute it. So then we can now simplify that a sub n is actually 500. Okay, is equal to 85 plus, so just distribute this one. So 5n minus 5, and then just simplify it a little bit more. So 85 minus 5 is 80 plus 5n. And then just transpose this 80 on the other side. So it will become now negative 80. So 500 minus 80 is equal to 420. And then for you to be able to get the n, so just transpose this on the denominator, okay, or cross multiply. Okay, so for 20 divided by 5 is equal to 84. So as you can see, we have a total of 84 terms out of this range. So from 20 to 103. Okay. So once we already know what is, or yeah, what is a total term, which is the same with this one, n minus n plus 1, then you can now proceed and then use this given formula. Okay, so a sub n is equal to n divided by 2 times a1 plus a sub n. So just substitute the corresponding values. So n is 84 divided by 2 times a sub 1 is 85 plus a sub n is 500. So 85 plus 500 is 585. 84 divided by 2 is 42. So 42 times 585, then you will get 24,570. Okay, which is the same with this one. All right. So I'll let you guys verify this one. Then let me know you have already understood it.
Understood naman po.
Understand?
Yes, sir.
How about the others?
Naintindihan naman, sir.
May naman parang 50-50 yun Alright, so you have two ways. So it is either you call this one. So it is either you simplify this formula or you can use those two formulas instead.
Sir, pero pwede gamitin yung naunang formula.
Yeah, you can use any of those two. So it is completely up to you.
Okay, sir.
All right. So once you're done in understanding those given examples and concepts, so you're going to have a seat break, of course. So this is your seat break number 3. So evaluate the following using arithmetic summation formula. So your starting number is 25 up to 50. So here's the formula. So 3 times 2i minus 5. And for number 2, so starting from 2 to 8, so identify the summation if we have this formula. So 2 times 5 plus 2i. Okay, so you can either use this one or this one. So are we clear so far?
Yes. Yes, sir.
How about the others?
Medyo
Yes, sir.
clear naman, sir.
Medyo. So I like that honest answer. So it's okay since this is actually a fast moving lesson, okay, or fast moving discussion. So that is why you have a lot of time to answer these given secrets. So you always have 1 week to finish everything. Okay. All right, so this is your secret number 3. So as usual, you can do this one handwritten and then just upload it on our canvas. All right, so if we have summation, we also have geometric summation formula. Okay, I'm sorry, we have arithmetic summation. We also have geometric summation formula. Okay, so geometric sum is a sum of portion of a geometric sequence and has the following explicit formula. Okay, so by default, we have this given formula already. Okay, so summation is ranging from 0 to n. So a times r raised to I. So as you can see, we are still using summation. Okay, so this one is the same with the geometric or the notation. Okay, so this is how you for this one elaborate that given notation symbol, and then by using this summation, then you can have the geometric sum of that given formula. So from here, as you can see, we will start with 0. So just substitute this one here for you to be able to get the first term. So any number that is raised to 0 is equal to 1. So a times 1 is a, which is now this one. And then, of course, the next one is 1. So r raised to 1 is r. So just add as it is. So a times r plus a r raised to 2, and so on and so forth up to raised to n. Okay, and then we have this explicit formula. Okay, wherein this one is actually the same with this one or equal with this one. Okay, so a times r raised to n plus 1 minus a divided by r minus 1. Okay, so if it's starting with 0, then you can use this formula. All right, so for now, I'll leave the uh, memorization part unto you later on. So for you to be able to understand this one a little bit more, we have this example. So evaluate the following using geometric summation formula. Okay, so we have here starting from 0 and then up to 13. Okay, and then we have this given formula. So 2 raised to I. So you can either use this one or you can do it manually. Okay, since there's only 13, actually 14 terms. But you know, why make it longer when we have the shorter solution? So just use this formula, okay, wherein this substitute their corresponding values. So a here is 2. Ah, sorry. A is equal to 1, okay, and then r is equal to 2. Okay, so apply this by using this geometric formula. Okay, so n minus 1 or n plus 1, sorry, is 14 since your n here is 13. So just add 1, then you will get 14. So if you're going to apply or if you're going to use this given formula, you have to use these values. So by default, a is equal to 1 and then r is equal to 2. So 1 times 2 raised to 14 minus 1 divided by 2 minus 1. Okay. So just simplify this one a little bit more, then you will get 2 raised to 14 minus 1. Then just solve this one using your calculator, then you will get 16,383. So that's the geometric sum from 0 to 13 having this formula. Oops, I'm sorry. So this one is not a constant or a fixed value. Okay, this one came from this formula. So your r here is 2, and then your a here is 1. Is it? Wait, I'm the one now who's confused with what I made. So apply geometric function of the setting a is equal to 1 and r is equal to 2. So 2 raised to I is equal to 2. 1 times 2 raised to n plus 1. Oh, yeah. So I think this one is a fixed or a constant value when it comes to using this formula. So we will verify later on if this one is a fixed or a constant value. Okay, so I'm not sure anymore if this one came from this formula because r here is 2, and then where this one came from because we've started with 0. So it's 50-50. So we will verify this one later on. But for now, just use this given value. So A is equal to 1, and then R is equal to 2 when it comes to using this given formula. And then take note, you can use this given formula as long as your I starts with 0 up to letter N. Okay, so the same with summation late a while ago. So you can use an explicit formula as long as it's starting with 1 up to N. But if it's starting with 3 and so on and so forth, then you can use the other formula. So were you guys able to grasp the idea regarding with this formula? Hello? Are you guys still there? So the only confusing part is this one, okay? The values of A and then R. So we will look whether this one is really fixed or no on the following examples. So for now, just follow this formula if we have a starting from 0 up to letter N. So are we clear so far?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Yes, sir.
So let's now proceed to the next one, hoping that we can solve this confusion right here. All right. So we have this geometric sequence. So the terms of a geometric sequence have the form of a sub I is equal to A times R raised to I. So for summation, we only have A sub I, or sometimes this is just only I. But in geometric, okay, we have this additional, or a revised version actually. So instead of a subscript, we have here a superscript or an exponent. And then we have an additional variable wherein R here is, where is that one? R, ano, I didn't indicate what is R in here. Anyway, A here is formula, and then R here is also a part of that formula, where A is the first term, okay, when I starts at 0. So as always, this one is the value of the first term if we have a given 0 for the starting point. So for example, we have this one. So what is A and R in the geometric sequence? So 2, 6, 18, 54, 162. So what do you guys think? What is our A? And then what is our R? So A is very obvious. So A is a first term. So A is 2. And then what is our R?
Sir, last term.
Yes?
Sir, yung last term.
Ano yan? Hindi ko masyado marinig.
I should be
Sir, yung
3.
last term.
What is that, Mr. Followe? I don't know if it's Mr. Gonzalez or Mr. Followewa.
I should be 3.
How you should do it? Just apply his formula. Okay.
Yeah, I said R is 3.
I'll is do it.
Yes.
Yung R daw po is 3.
I is 3.
Yung R po, 3 daw.
R is 3. I'm sorry. Okay. Someone chat. So, sir, last term. No. R is not our last term. So, basically, this is just our multiplier for you to be able to get the next term. Okay. So, for example, you have raised to 0, right? So, this is your first term, which is 2. So, 2 times 3. So, we will put here 3 since this is the assume next value. It's just multiplied by 3. Okay. And then raised to 0. So, any number that is raised to 0 is 1. So, 2 times 1 is 2, having now the first term. And then if we have the second term, which is now raised to 1, so 2 times 3 raised to 1 is 6. And then getting the second term is 2 times 3 raised to 2, wherein you will get 18. Okay, and so on and so forth. So A here is 2, and then R here is 3. I here is already given, so as always, you will start with 0, and then incrementing by 1. So raise to 0, raise to 1, raise to 2, raise to 3, raise to 4, and so on and so forth. Okay, so that's how we've got the value of A and R, right? So we have this given solution. So I thought I wasn't able to put the solution. So here, so what is A and R in geometric sequence? So the same question, and then the same kind of solution, which is this one. So A sub 0 is 2, and then A sub 1 is 3. Why A sub 1? A sub 0. All right. So still 14. Anyway, we will start without the other one or without the other two. So this is where we've stopped. So can you guys see my screen now?
Yes, sir.
Yes, sir. Yes.
So again, we have this given example a while ago. So 2, 6, 18, 54, and then 162. And then just by applying this formula, then you will be able to get the following numbers. Okay. So in here, we already know the A sub 0, which is 2. So for us to be able to know how did we get the second value, which is A sub 1, so just multiply or just find the multiplier since we are in geometric sequence. Okay, so the multiplier to get the 6 is 3. So 2 times 3 is 6. So we have to prove the following equation whether this one is really true or no from or for the following equation. So 2 times 3 raised to 1 is 6, and then 2 times 3 raised to 2 is equal to 18. So as you can see, this is the A sub 0, A sub 1, A sub 2, A sub 3, A sub 4. So those are their positions. So A sub 0, A sub 1, A sub 2, A sub 3, A sub 4. So is it true up to A sub 4? So just by substituting this one or just by following this formula. So 2 times 3 raised to 4 is 162. So from here, we have proven that your A is really 2, and then your R here or your multiplier here is really 3. Okay, and so on and so forth. So I just didn't show the following terms after 162. So the first 5 terms only. All right, and then from here, okay, so this one is a fixed value. Okay, so if you're going to apply this one, okay, and then it's starting from 0, then you can use this one. So by default, A is equal to 1, and then R is equal to 2. Okay, so the only thing that matters is as long as you know the maximum limit, okay, which is this one. So 13 plus 1, so just keep on adding 1. So 2 raised to 14 minus 1. So if this is 17, so or your let's say your maximum limit is 17, so just add 1. Okay, so 2 raised to 18 minus 1, then you will get the geometric sum of this given equation. All right, so as usual, once you're done in understanding this one for this formula instead for geometric sequence, then you can now proceed and start answering the seat break number 4. So the same with our example, what is the value of A? So this is like a bonus already. You already know the value of A from number 1 and number 2. But what is R for this given sequence? Okay. So this will only take you maybe more or less 5 minutes. So you can do the same, just like this example. So you can already answer your A, and then identify what is your multiplier or what is your R. Okay, and then you have to prove uh, that one using the equation. So A sub 0, or just by using this formula, A times R raised to I, to get the A sub 0, A sub 1, and so on and so forth. So is this clear so far?
Yes, sir.
How
Yes,
about
sir.
the
Clear
others?
naman po.
Yes?
Yes, sir.
Yes, sir.
All right. Okay. So we also have here the double summation. Okay, and then at the same time your seat work number 5. So evaluate the following equation. So initially we have this one. We have double summation. So we have letter I and then letter J. Okay. So summation from I, or from I to 4. Okay. And then summation from J to 3. Okay. So both of them started with 1. So you can simplify this one just by distributing your letter J first. Okay. So as you can see, we've retained this summation I up to 4, and then just distribute the value from 1 to 3. Okay. So take note, since this one is summation, so we will use addition. Okay. So I plus 2I plus 3I. So where did this value came from? So it's from 1 to 3. So it's like 1I. So basically 1I is the same with I. So we've just removed the 1 plus 2I, which is now your second term, and then plus 3I, which is now your last term. So you can simplify this one a little bit more. So just add everything. So I plus 2I plus 3I is equal to 6I. So once you already have this one, then you can now distribute your I. So again, this one is ranging, or this I is ranging from 1 to 4, or summation from 1 to 4. So, just substitute their corresponding values. So 6, which is this one, and then your I here is a summation of 1 to 4. So times 1 plus 2 plus 3 plus 4. And then if you're going to simplify this one, then you will get 60. Okay, so that's how you simplify a double summation. This one is actually quite simple. Then, after you were able to understand this one, then you may now proceed in seat break number 5, wherein you're just going to evaluate a double summation, but just a different starting point and a different upper limit. So you can do this one handwritten. Then again, please write logically. Okay?
Excuse me, sir. Since this one is not starting at the same point, how do we attend to this?
If they are not the same,
Yeah,
the same what? Not the same in terms of.
starting point. For the example, I equals to 1, J equals to 1. But for the seat work, I equals to 0, J equals to 1.
So that is the twist part. Okay, so it is now your uh, research work on how you will identify if it's not starting with 1. Okay, I think it's quite the same. Okay, so instead of having this I here, so what will you get? 0 times I. But in here, since we've started with 1, so 1 times I, which is the same with I. I think that's the only difference. Can you understand it now at least a little? So if not,
Just a little.
just a little. So if not, there are lots more examples from the internet, but this one is the simplest form when it comes to double summation. So there are others which are more complicated. But if you can find something like this, okay, wherein we have a starting point of 0 or starting point of 2, then same format. Okay. You can follow this one as it is. All right. So any other concerns so far?
No, sir.
All right. So let's now proceed to the last topic, so which is strings. So this one is a sequences of letters or other symbols written without the commas. So it is the opposite, or it is the way on how to uh, get the sequence into a certain uh, word or a certain letter. So for example, we have this sequence STURDY. So the string of that one is 1. So just simply removing the comma. Okay. We call this one string or a word or what's one? A text. Okay. So we simply removing the comma. So the same with this one, just remove the comma. Okay. So they know this is a sequence, and then this is now the string format. Just by removing the comma, and you will get the string format right away. Okay. So what is this string format for? So what is saying it's a set corresponding to a sequence. So it is set of all distinct elements in a sequence. Wherein, if you're going to recall, in a string or in a set rather, in a set, it is separated by comma. Okay, but this one now, if there is no close and open parenthesis, close and open bracket rather, this one now is the sequence. And then if you're going to transform this one into string, then just remove the comma. Okay, so this is the set, and then this is the sequence, and then just remove the comma 1491625, then that is now the string format. Okay, so it's like basically transforming a set into a sequence into a string. Okay, that's the origin. Okay, so the same with this one. So we have this set, and then we have this sequence or string rather. Okay, this is already a string because there is no comma in here anymore. Right, so just take note that in sequence, the order of the elements is important. Okay, so in here you cannot shuffle this one. Okay, but in set, of course, you can shuffle it. So 25, 4, 9, 1, 16. So regardless of the arrangement. But for sequence, so whatever is the first one, it should stay as it is. Okay, don't put the second term on the first term, or do not put the last term on the first term. So in a sequence, order is very important. But for the set, again, it's not important. Okay. The elements order is insignificant. Order I, the elements order is insignificant. Okay. So number 3 here is like an example. So give 3 different sequences that have X, Y, Z. So this is a set wherein arrangement doesn't matter. So the question here is give 3 different sequences that have X, Y, and Z as corresponding set. So what are those sequences? Anyone can give? So I'll just write it here, but I'll erase it later on. So for your first sequence, so you can have z, y, x, okay? Or you can have x, y, z. Or you can have y, z, x. So those are the three sequences. So z first, and then x first, and then y first. So those three are different when it comes to sequences, but of course, when it comes to a set, they are just the same. But then again, since arrangement matters in a sequence, so those three are three different sequences. Okay, so are we clear so far regarding with strings and sets and sequences?
Yes, sir.
Yes, sir.
Opo.
All right. Okay, so let's have more examples when it comes to a string. So give the set corresponding to the sequence. So this is sequence, and then here's the set. So you already know this one. So again, in a sequence, this is the format. So that's your arrangement. So we don't arrange it anymore since that's the default one. So the question here is the set. So what is the set out of the sequence? So again, in a set, there is no repeated values. So you should only put 1, and you should only put 1, 2. Okay, 1, 1, and then 1, 2. That's why we have 1, 2. So you can answer here 1, 2, or 2, 1. So doesn't matter since this one is a set. And then we have here the sequence, and then we have here the set. So as you can see, the only difference here is the close and open bracket, and then the arrangement when it comes to the sequence. And then at the same time, for the set, of course, you have to remove the repeated values. So since there is no repeated values here, so just copy as it is and then just put it inside the bracket. So this is now a set. Okay. So we also have this one from AA, BB to ZZ. So since there is no repeated elements, so you can just copy as it is and then put it inside a close and open bracket. All right. So any questions so far?
No, sir.
Wala naman po, sir.
All right. So let's have more example, which is the most origin when it comes to strings. So string with no elements is denoted by this. I don't know if this is lambda. Forgot. So we have this symbol wherein indicating that there is no elements or there are no string on that given sequence. So actually it's nothing. Okay. So this one is the same with null or empty set when it comes to set operations. But for string, we have this symbol. Okay. And then the length of the string is denoted by this. It's like the same. So we have this what do you call this one? Forget that term. The what is that again in this set operation? Cardinality. Okay.
The cardinality.
Yeah, cardinality is the count of total of elements inside of that set. So we also have the same when it comes to string. And then we have this one special symbol wherein x, and then it has an asterisk on right, upper right. So this one denotes the set of all strings over, over x, okay, or over this symbol or variable rather. And then we have this plus, okay. This one denotes the set of all non-null strings over x. Okay. So let's have an example for you to be able to understand what are those given symbols. So let x is equal to a set of AB. Okay. And then some elements of x asterisk. Okay, so if we have this kind of symbol asterisk, you have to identify all of the possible strings over this variable, which is your x. Okay, so from here we could say that we have the empty set, okay, or the null set in set operations or lambda, and then we have here the a, and then the b, and then b raised to 20, a raised to 5, and then b a. Okay, so if you're going to take a look at this one, all of this uh, can be inside of this set. Okay, no matter how many 20s or how many b's you have. So we have 20b, we have 5 b's, and then followed by 1b and then 1a. And then we have AB, which is just the same with this one. So maybe you're wondering where this one came from or where those two came from. So actually, it's just an exaggeration. Okay, so this one is a set of all strings over x. So we could say that this one has no limitation. So you can have 1,000 or 1,000,000 A's, or you can have 2 billion B's. Okay, just to indicate that it's all elements or all strings under such variable. So initially you can just have this one lambda and then a and then b, since that is what's really inside of this set. At the same time we have this one. Anyway, so let's have this example. If alpha is equal to AAB and beta is equal to a raised to 3, b raised to 4, a raised to 32, then alpha, or the cardinality of alpha, is 3, and then the cardinality of beta is 39. So why 39? So just simply add the exponents of those given variables or given elements. Okay, so this one is an indicator that we have 3 A's, 4 B's, and then 32 A's. Okay, so of course, since we are in a sequence, so you have to count everything. Okay, so we have 3 plus 4 plus 32, which is equal to 39. All right, so are we clear so far regarding with this example? No? Are you guys still there?
Yes, sir.
Yes, sir.
All right. So do not mind this one. Okay, this one just might confuse you. Anyway, this one is, just to indicate that you can have many A's, you can have many B's. This is just the same with this one. All right, and then this is how you count the cardinalities of a given string. Okay, the next one is concatenation. So you guys already know what is concatenation. So for example, if alpha and beta are two strings, the string consisting of alpha followed by beta, written as alpha beta, known as concatenation. So as you can see, we have two different strings, and then just by simply concatenating them, or just by putting them aside or side by side, alpha beta, we call that one concatenation. Okay, so we have this example. We have this, I don't know what is the name of this symbol, which is containing AEB. And then we have this one. Is this omega? The W? Or no? Omega is, yeah, this one is not omega. Anyway, this one has a string of CABB. Okay, so it is asking us to concatenate those two symbols. So this one first, and then followed by this symbol. So what is the value or the content or the string of this one? So it's AAB, and then followed by CABB, which is this symbol. Oops. And then the last one here, after the second to the last, is the so instead of having this one at first, we have this one at the last, and then instead of having this one at the last, we have this one at the first. So they just interchange. So of course, CABB followed by AAB. Okay. So just simply, put them side by side, depending on their arrangement, of course. And then we have this symbol, which is this one. And then we have this lambda. Okay. So lambda here is no elements. So you can just simply remove that one and then retain this one. Okay. So what is the string value of this one? So it's A, B, B. All right. So that's how you concatenate a string. Okay. Super easy. It's like a bonus already. So any questions so far?
No, sir.
Wala naman po, sir.
All right. So strings are just like a bonus. Okay. This one is super easy. Anyway, once you're done in understanding those examples and concatenations, then you can now proceed and answer the seat break number 6. So we have this given sequence. So find s of 1, s of 4, and then write as a string. So take note, this is just a sequence. Write this one using in a string format. All right. So that's it for the module 3. So any question or clarification so far?
Wala
No,
naman po,
sir.
sir.
Answer.
Right. So if you have a question or clarification in the future, then feel free to ask me anytime. So you can chat me or message me via Canvas or through my Facebook account. All right. So if you guys do not have a question anymore, then that's it for the module 3. Then just answer the activities on our Canvas. So next meeting, we will finish the module 4. All right. So goodbye and thank you for coming. Okay.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank
Thank you, sir.
you.
Sir, pwede na malis, sir.
Yes, yes. So you guys may now go.
Thank you, sir. Bye po.
Goodbye.